Hello, everybody. Welcome back to Planet X News. I'm here this afternoon or this early evening with Dr. Claudia Albers, our Planet X physicist. And NASA just announced that they're going to be launching the Parker Space Probe. And if any of you don't know anything about the Parker Space Probe, last year during the eclipse, Dr. Albers, when was the eclipse?
August 21st, 2017.
Yes. August 21st, 2017. Let me just adjust this a little bit. There was a lady scientist who works for NASA. She was at one of the locations viewing this so-called eclipse. Some of us believe it was a real eclipse. Some of us don't. I'm one of the disbelievers. Dr. Albers, what about you?
Well, I definitely think it was fake. It was so fake. It's just, I mean, the moon moved to one side and then to the other, or up and down. And it was just so strange. You could look at it with your naked eyes, and you're not supposed to be able to. No, it was definitely fake.
Yeah, I mean, I watched it too, and I saw many different videos of it. But during some of the NASA TV interview, this lady pops on, and she's being interviewed by the NASA so-called TV reporters. And all of a sudden, she just starts talking about kissing the sun with a new NASA space probe that they were about 1 year away from launching. Then she starts going into talking about it, getting ever so close to the sun. I find it kind of ironic that all of a sudden, you know, after all these years, now all of a sudden, NASA wants to build a space probe and send it straight towards the sun. Well, what are they looking for? Well, they're going to tell you, because a lot of press releases have been out there. I've been following this now since the day I heard that interview. Now, in the interviews that we're going to show you tonight, you're going to see the same lady from the UK, works for NASA, and she's back doing her soft disclosure. Me and Dr. Albers have been discussing this. We have some theories, we have some thoughts, and there's a lot going on with the statements that NASA is actually making about this space probe. Some of them don't make sense. And there's a message in there from NASA's scientists on this space probe program that fully admit that there is so much that they don't know, and this probe will tell them a lot more. So here's my point. If we're talking about some of the leading scientists in the world working on this multi-million-dollar space probe being attached to a V4 rocket, they call the V4 Heavy, they're going to launch this spacecraft to the sun. It's going to take years by the so-called spiraling orbit that it will go in. They're saying that it's going to be traveling at 434,000 miles per hour. It will make it as close as 3.8 million miles away from the sun. They referred to it as the Parker Space Probe kissing the sun. Well, we know that would be impossible, but there are just so many weird things that they're saying. But one thing they are confirming is that they know very little about the sun, about the solar wind, about the cosmic rays. So my point is, if the leading scientists building this spacecraft, working for a government agency, NASA, funded by taxpayers, if they don't know all that much, how are you to respect the views of, let's say, a so-called YouTube professional debunker who claims they know it all when they don't know anything at all. So they're telling you that NASA doesn't know anything and they know it all. Does that make any sense to any of you? If the leading scientists admit they know very little, how do you respect somebody coming on to YouTube, making ridiculous videos, maybe talking the talk, and making you believe what they're saying? And they're not a scientist. They're just a little amateur debunker on YouTube. They hold no credentials. Some of them hold no jobs. Some of them are still living with their mommy. So let's just put that to rest. Dr. Albers, what do you think about this announcement for the launch?
Well, I find it very strange, especially since they kept saying, oh, we don't know much about the corona. Basically, they're launching the spacecraft so that it will go to the outer corona, the outer edges of the sun's corona. And we do know, well, they've been telling us that the temperature within the corona is several million degrees Kelvin. And basically, the spacecraft can only take, has a heat shield that allows it to withstand temperatures of 2,500. So I don't know. Are they now saying that the corona is not at millions of degrees Kelvin? I think that's what they mean. And that basically they're saying they don't know much about the sun. They don't know what causes the solar wind. They don't know why the corona is hotter than the surface of the sun. And basically they're saying they don't know anything about the sun. But yet solar scientists have been claiming for years that they know everything about it.
Exactly. You know, I could see it's the shock of it is stumping you just as it stumped me when I heard the press releases.
Yeah.
So, you know, from time to time, I listen to some of these other idiots on YouTube with their their ridiculous debunking techniques, their little George Soros deep state tactics. And, you know, some people fall for it. You know, some people like their demented personality. Who knows? But when I look at these leading scientists forcing this soft disclosure. So what they're saying is, okay, we built a spacecraft. We had to build it. We did a soft announcement during the eclipse on NASA TV, which probably nobody paid any attention to, but I know I did. I recorded it and I played it over and over, and I picked this lady's interview apart. And what she was doing was a soft disclosure back on August 21st, 2017, during that eclipse. The same lady, I'm going to show you all of the video information on this, all of the press releases, okay? And how they designed this craft and what it's going to have to go through. We're going to detail that for you. We think that they're actually up to something else other than going out to kiss the sun. So I'm going to share my screen. We were trying to work on the technical issue with the sound so you guys can hear it. I may have to turn the volume up a little bit. Turn the volume up on whatever you're watching us on, your cell phone, you know, your big flat screen TV, your home computer. Turn the volume up a little bit as I play these videos for you on these press releases. So just bear with me. I'm going to share my screen. Let me entertain you. What do you think, Dr. Albers?
Yes, NASA's very entertaining, especially with all their CGI footage.
Oh yeah, there's something else I want to point out with you guys tonight. Excuse me. I'm getting over my allergies are killing me. You know, we look at the SDO footage of the sun, and you know, the quality is so. It could be tremendously better, and that's what they show us here, you know, in public land. But you're going to see them and their views of the sun from the SDO spacecraft, and you're going to see the difference in what they see and what we see. But anyways, if you go to the NASA website, punch in the search up here, Parker Space Probe, right there. And, you know, I'll put the link. Matter of fact, let me do that real quick. I'll put this link in the description box. Or not the description box, the live chat. Any of you want to check it out, you know, go right ahead. Let's get back to this real quick. So going back, this is the latest press release that just came out, and they're talking about launching this on August 4th. So it will be pretty close to 1 year for this launch. There's a lot of information here on all of these. These are all articles and video articles. Excuse me. They even have some download HD multimedia stuff. Follow their rules. You know, if you want to put it in a video or put it up on a website. But I'm going to play this video right here. And this is the latest. And it states NASA 4K ultra high definition video countdown to T0, flying faster, hotter, and closer than ever to the sun. I want you to analyze the commentary in this video, and I want you to analyze the content of it. I don't care if you have to go to the website, click on the video, or watch this live stream at this portion just to analyze the people and analyze the video. And we know NASA kind of talks around a little bit in those secrets with all of their symbolisms on their patches and things of that nature. I was picking up on it. One of the key words you're going to hear a lot is the word alliance. Alliance. Now, if you guys know anything about the SSP and the secret space program, you would have heard this word alliance quite a bit. But anywho, let's play this first. Let's play this first portion. I'm going to go ahead and expand this, and you could watch it. Look, you can watch it all the way up there in 4K, high definition, 1080. We'll watch it in 1080. Mm-hmm. I'm going to have to turn it up. You guys turn your volume up because the sound quality with Google Hangouts, there's not a direct link for your speakers that I know of, but I'll turn it up.
The sun, the heart of our solar system. It's as familiar as anything we know. Although the sun has been studied for millennia, it still holds unsolved mysteries about its effects on our daily lives. To better understand the sun, NASA is preparing to launch a spacecraft called the Parker Solar Probe. It will lift off from Cape Canaveral Air Force Station near the agency's Kennedy Space Center, located in Florida. It's a mission of unprecedented opportunities that could revolutionize our understanding of our star and the outer layer of the sun's atmosphere, the corona.
Going into the sun's corona for the first time,
real quick, ladies and gentlemen, this is the British lady that I was just telling you about, Nicola Fox. Okay, Johns Hopkins University Applied Physics Laboratory. Okay, she's a pretty smart lady. This is the lady who gave the soft commentary, the soft disclosure, I think, on August 24th, 2017, during the eclipse on NASA TV. This is the lady's interview that, you know, I analyzed for hours. I watched it over and over again. I watched her body language, her hand movements, her scripted interview. And once again, what's that, Claudia?
I think what you said, scripted, tells us everything.
Oh, yeah. Yeah. No doubt about it.
In other words, she wasn't thinking. She was just saying what she'd been told to say.
Exactly. But I'm going to go ahead. We're going to play this real quick. We'll just dip it back here.
For the first time, going up corona for the first time, going up close and personal with our star to be able to answer some of the mysteries that live in this coronal region. Why is the sun's corona hotter than the surface of the sun? Why is there a solar wind? Why does this atmosphere, this corona, become so energized that it can move away from the sun at supersonic speeds and bathe all of the planets?
Now that the Parker Solar Probe has arrived, it's time to get it ready to launch at the Astrotech Spacecraft Processing Facility.
Today's an exciting day on the Space Coast. Over at Astrotech, we'll ready their spacecraft to launch. That'll include any final assembly, including the assembly of the critical heat shield. We're going to be 24/7 helping the spacecraft get what they need to get ready for launch.
The Parker Solar Probe will be the first mission to travel through the searing heat of the sun's corona. Traveling this close is only possible because of the spacecraft's protective heat shield, where temperatures on the spacecraft reach 2,500 degrees Fahrenheit.
So Parker Solar Probe is actually going and touching the sun. The previous missions have been really important for solar science as we study from afar. And we can learn a lot from studying from afar. But Parker Solar Probe is actually going and touching, almost kissing the sun. So we can learn so much more.
And to do that, it will need to go faster than any other spacecraft in history.
When we launch, Parker Solar Probe will be the fastest human-made object ever. We are traveling at an unbelievable 430,000 miles per hour.
That's why, for the first time ever, NASA's Launch Services Program selected the United Launch Alliance Delta IV Heavy rocket.
Delta IV Heavy was selected for NASA Parker Solar Probe program because of the
There it is, ladies and gentlemen, right there, staring you right in the face. There's part of their symbolism. You see the pyramid, the Roman numerals, key words, United Launch Alliance.
Mm-hmm.
It's all staring at you right in your face. There is way more to this launch than they're telling us. And remember, everything you see sitting there is United States taxpayers' dollars and probably money from other countries who may be part of this so-called space alliance. Dr. Albers and I both feel that they're definitely going out there. They definitely, you know, have this technology all of a sudden within the last year. We're going to discuss some of this technology and some of the, you know, incredible feats that it's going to have to go through. But I just wanted to point that out for you right there. That's a screenshot. Analyze it. Let's go ahead and play this some more.
4 Heavy was selected for NASA Parker Solar Probe program because of the extreme velocity required to meet the mission objectives in orbit around the sun.
Going out and seeing the Delta IV Heavy on the pad is a truly awe-inspiring experience. Just seeing that amount of raw power right in front of you is just incredible. 3 boosters, our second stage, and then we have a third stage. We're a tiny little spacecraft. We look like a little hood ornament on the top of the Delta IV.
Get ready to watch this historic mission, lighting up the Space Coast as it thunders into the sky to get up close and personal with the sun.
Well, listen, folks, you know, I don't know about you guys, but we see the symbolism. Very, very scripted. Of course, you know, it's a production video. I mean, it would be. But that's the same lady That's the same British lady with the British voice, real proper. And she's the one who did the soft disclosure during the eclipse. Now, you guys can analyze this video, but I'm going to turn this over to Dr. Albers, and she's going to give you more than her 2 cents on this spacecraft and what is known of the sun now and this technology in order for this small spacecraft, which is, as they calling it, no bigger than a subcompact car. Okay. And very, very delicate equipment, transmitters, detectors, sensors, and I could guarantee you some infrared cameras and state-of-the-art, the best camera systems for space. They're on this craft. They would have to be. Why wouldn't they be? So, Dr. Albers, I'm going to go ahead. I'm going to turn it over to you, and we'll use a little bit of the backdrop here.
Well, they said they're going to get it up to a speed of 430,000 miles, which is very high. I mean, if it went in a straight line towards the sun, it would take 9 days to get to the sun. So that's a very high speed. The thing is, spacecraft have never been launched to go directly to the sun. The closest they usually get to the sun is the L1 position, which is 930,000 miles from Earth. So it's only about 1% of the distance between. It's very close to Earth still, to Earth's orbit. Now they're launching a vehicle into the sun's corona. Basically, this spacecraft would be hit not just by the particles that are at millions of degrees Kelvin that are coming in the solar wind, which is this spacecraft is supposed to study, but these are charged particles. They would induce currents in the spacecraft, in the electronics, and I think they would fry them before the spacecraft got there. And then the other thing is that in the sun's corona, the gravitational force of the sun on this object would be extreme.
Yeah. See, folks, there are so many things that just don't jive, as I would say. Debunkers claim that, oh, you can't get anything like a planet that close to the sun within the sun's corona. It would be ripped apart. It would be this. It would be fried, blah, 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 blah. Okay, well, NASA is defying that by sending a small space probe, no bigger than a subcompact car, approximately 3.8 million miles away from the sun. So, you know, in astronomical terms, that's pretty damn close. But yet, this little small subcompact car size probe is going to make it.
Yeah, and the other thing is, Scott, this thing has a heat shield that would protect it from these particles coming from the sun. But how is this object going to observe the sun since the heat shield has to always point towards the sun because that's where the particles are coming from? How is it going to manage to point its detectors towards the sun with the heat shield in front of it?
Yeah, that's
going to point a camera, which would be easy to damage by all the radiation and cosmic rays at the sun at the same time as the heat shield. That's just not possible. How have they worked that one out? I'm not sure.
I know. Because we could take a quick look. Tell you what, we'll pull this up here. We'll get a good look at what this little thing looks like. Let me wait till it gets over here.
Yeah, you see, it's got the heat shield in there, but how does it point its...
This is the heat shield.
Right.
Okay. It is made of some lightweight, futuristic carbon fiber. I think it's approximately 4 inches thick. They said it consists of almost like foam air. And it's going to be shielding the entire craft. But yet the heat is everywhere.
Yeah.
And just because you have some little shield in front, I don't think that's going to actually protect all of the electronics.
Definitely not.
From the sun's magnetic field.
Yeah. And look at the position there. It's not even directly, the heat shield's not even directly pointing at the sun right here. So it would get hit by the radiation from the side, just in that position that we saw it there. And plus, the heat shield is not protected from the induced currents due to these charged particles going past.
Yeah, I mean,
like an EMP all the time. How's it going to work? It's not inside a Faraday cage. The only way to shield it from that would be to put it in a Faraday cage, put it into a metallic body, and charge the body to very high electric fields. They're not doing this. They're not shielding this thing against these electromagnetic currents induced by these particles. I really don't understand what they are talking about here. How are they going to get this object to survive under these conditions? It's like they are admitting that the sun is, well, we don't know anything about the sun, but maybe the sun is dying, like we're saying, and so it's so weak now that we can send this probe out to it as if it was a planet.
Aha! I agree. Now it looks like there's a little something right here on the bottom of this animated model, and here's your supposed heat shield. So maybe they got some robotic arms that can come out and produce some type of camera detector or whatever. But ladies and gentlemen, our point is they're saying that the heat shield's maximum temperature that it could accept is 2,500 degrees. 2,500 degrees at approximately 3.8 million miles away from the sun. So in actuality, it's not going to go up and kiss the sun like they are saying. It's going to be at least 4 million miles away as it spirals in over a course of, I think it's about 9 years. But who knows? That's the orbital pattern that they're giving us. Now, like Dr. Albers said, if it was a straight shot, it would take about 9 days at the speed and the distance to get it to where it's going. Mm-hmm. Many probes like this have been lost in space many, many times by the Russians, I think the US. And this is supposed to be record breaking. There was the last spacecraft, I think it was called the Helio 2 or something like that. It got pretty close. It got, I think, within inside the orbit of Mercury. I'm not sure. I'd have to go back and check. But Dr. Albers and I think that it's very ironic that all of a sudden, after all of these years in space technology, space exploration, now, through the course of the last year, now they want to send a sophisticated probe to the sun because they've just now admitted that they know very little. And once again, some 2-bit debunker on YouTube, then that means you don't know anything. Only what you've been told and led to believe. So I think we've crushed all of that crap.
Yeah.
There's a lot of things that kind of don't make sense, but they are making sense now. Like Dr. Albers has been saying for, the last year and a half, our sun is taking a beating by these objects. The direct interaction with this Planet X object or objects and our sun, it's bleeding our sun. And if in fact our sun is truly going into a solar minimum, meaning it's already weakened, our magnetosphere will then weaken. More cosmic rays and solar radiation will penetrate the Earth over a very long period of time. Is there something else out there that they don't want us to see happening, such as the sun weakening to the point we would be able to visualize it and see it and experience it from Earth?
Yeah, that's a good question, because what have they put in place so we don't actually see what's going on with the sun is
the sun simulator.
The sun simulator and the chemtrails. And as I discovered, the sun is not emitting light all the time, and it's getting eclipsed by these objects, and they're hiding that fact from us with these sun simulators. And we know that something dramatic is most likely happening with the sun. Maybe it's in a worse condition than we even realize. So what would they do with a spacecraft like this? They send it out to the sun. They take measurements about what's going on, and they give us CGI pictures to give us this idea that the sun is still fine.
Yeah, because some of their pictures that they were showing looked like replications of the SDO footage. And I mean, that was, that's beautiful, high definition 4K video. Where the hell are they getting that from? Because that's not what we're seeing.
Yeah, that's
not. That's what we don't get to see that on the SDO public access. Hell, we're paying for it.
Yeah.
So, folks, I wanted to bring this to your attention because, there's a lot. There is a lot that I pay attention to. I pay very, very close attention to what is going on with NASA, the European Space Agency. I do go to their websites. I do peruse around, and especially when they're building, rockets, space probes, satellites, things of that nature. If they're making some of the information public, I do check it out. No doubt about it. A lot of symbolism in here too.
Yeah, I was wondering why they had that purple light.
This up a bit.
That was strange. Why were they using a purple light? The thing is, they tell us very little about what's actually going into the craft and the real dangers it will encounter. It's just like a little bit of information that leaves you with more questions than answers. They don't give us specific information about what's going into the craft, how they mean to protect the craft from different dangers it will encounter in the sun. Surely that's the kind of thing that they should have prepared and talked about. That's what's most important. That's what's most interesting. But the fact that they haven't gone into that, I mean, any physicist would start asking, okay, but what's this thing going to encounter? We know we have these particles in the solar wind. How are you going to protect the craft from it? But they haven't actually given us any of that information. It's very, just very basic information they gave us, almost as if they're talking to us as if, we're school children. We need some more details. They're not giving us those details. So to me, this is more like Hollywood production for the masses. Look what we're going to do. We're going to show you the sun. Hey, you're not allowed to see the sun from the surface of the earth. We don't let you see it, but you're going to be able to see it through the detectors on the spacecraft. And then we can feed you anything you like.
Yeah, there's a lot about this project that I'm not buying, you know.
No,
I'm dead serious. It's going to be very interesting to follow it after its launch. The actual launch, we're going to go back to some of this information on this launch. Go back to the actual overview here. We'll scroll up there. Blah, blah, blah. Launch window between July 31st and August 19th, 2018. I think there was, they pushed this up, and there was some mention about August 4th. So between July 31st, August 4th, they have this window, and they're going to launch this puppy up there. And it's on a V4 heavy rocket, man. The biggest rocket launched from this planet into space.
Yeah, possibly because they needed to reach a high velocity to go, probably it's going towards Venus, and then it's going to slingshot around. And they needed to get to a high velocity to escape Earth's gravitational attraction. So,
yeah, it states here, at its closest approach, Parker Solar Probe hurtles around the sun at approximately 430,000 miles an hour. So that little space probe out there, it's about the size of a compact car, is going to be traveling at about 430,000 miles under the most extreme conditions. It states right here, where my cursor is up here in this section, to perform these unprecedented investigations, the spacecraft and instruments will be protected from the sun's heat by a 4.5-inch thick carbon composite shield, which will need to withstand temperatures outside of the spacecraft that will reach nearly 2,500 degrees. I was reading more about this, and it says that the internal temperature of this space probe will never a room temperature.
It's funny.
Okay, I swear to God, folks, it's in this information. So, you know, like, why not take like a YouTube troll?
Yes,
I'm joking here. Strap them to the inside of this thing, make it a little bit bigger. And, you know, since the inside is only going to be room temperature, that human being can survive. You know, we can maybe give him some of that space food to take along for the ride, and he could report live from the freaking sun.
Yeah.
I mean, some of the ridiculousness.
Yeah, I mean, it could be a manned mission, Scott, definitely, because, I mean, it remains at room temperature inside, and there's no problem with cosmic radiation, so, well, they could put a person in there.
Yeah, they can, man. They could put a human in there. What's the guy's name out there on the West Coast? Twatter. Yeah. Maybe they could strap his big mouth on the inside of this thing, and he could report live from the sun, letting everybody know that the earth is not flat. But anyways, folks, I mean, this is where we're at with some of this. You know, this to me, once again, is telling all of us here on planet Earth that the space programs are hot and heavy to get out there and learn some more about the sun. And not just necessarily about the sun, but what's happening to the sun. They know damn well what is causing it. But I actually think that besides getting up close and personal with the sun, kissing the sun, I think they're actually going out there, getting closer to the sun within 4 million miles to make another observation.
Yeah, the other thing is did they say it's going to move around the sun at 430,000 miles per hour?
Yes.
That's 119 miles per second. And that's way higher than a comet's reach when they just go, they go right up to the inner corona. They go at about 40 kilometers per second. So this is a higher speed than comets would be going. This doesn't make any sense. That's an orbital speed that will take it right into the sun, not the outer corona.
Well,
that doesn't make any sense.
Let me ask you something. How do you think that solar scientists and astrophysicists, all of these NASA guys that come up with all of this information and these stats and statistics and analyzations, do you actually believe they know how hot the outer corona of the sun is and why it's hotter than the actual bubbling surface of the sun? I mean, how are they actually getting that temperature?
Yeah,
how are they getting like even the age of the sun?
Yeah, basically, for the first time, they've admitted they know nothing, because what we actually found through the stellar cores, and this is why they don't want us to know about the stellar cores, is that all that is completely wrong. The sun is not anything like what they've been saying for decades. The sun is like.
Yeah.
So it's acting in a totally different way. The stellar cores show us that stars have dense cores, solid cores inside them, just like planets. And so basically stars are not much different from planets, except they emit a lot more light from their atmospheres than planets do. But they're electrical. Everything's electrical, and they deny that anything's electrical. Everything about the solar system is electrical in nature, but they will not admit that. So how can they even ever understand how the sun works? It's like trying to understand life, but saying life has nothing to do with the ingestion of food. How can you ever understand life that way? It's impossible. So, do you know what else, Scott? We actually found out that there's plenty of evidence that by the 1950s, they had the capability to take things in orbit using electrogravitic propulsion. So, for NASA to still be using solid rocket fuel, the brute force method of getting things into orbit, is ridiculous by itself. So,
if you remember, the secret space program is completely detached from NASA. So the secret space program may be the only program that has that technology, and NASA's still using solid rocket boosters, firecrackers, to send little subcompact cars with some space age 4.5-inch thick foam detector that can withstand 2,500 degrees and block all the radiation. Here's my point, ladies and gentlemen. Wayne Steiger and Dr. Albers were talking about the cosmic radiation that people are now receiving in much higher levels from flying in an airplane, commercial airplane, pilots, passengers, everybody on board. So if they've had this space-aged carbon fiber protectant, why haven't the jets, the commercial jets, on this planet been? How come they haven't been retrofitted? Why are we still allowing people to fly and be subjected to having a chest x-ray for like an hour, 2 hours, 4 hours, 8 hours? So, you know, there's a lot of questions that arise here. Now, what about the radiation? If they're able to protect this little spacecraft from that amount of radiation in the sun's solar wind, why aren't we using that technology for the common man? Because I'm sure there are some applications for that related to commercial air travel. Huh?
Yeah, I mean, they usually launch vehicles in such a way that it doesn't go through the Van Allen's belts because they can damage spacecraft. But you're going to get a lot more radiation in the sun's corona than in the Van Allen's belts. I mean, this spacecraft is going to get hit by CMEs.
Oh yeah, that's another big a big variable right there. You know,
solar flares.
Oh yeah, I mean, we were just talking about the other day about the instability of the sun. The possibilities of it are absolutely great.
Yeah, the sun is actually getting more active, and it has been getting more active for about 150 years at least. And that can be seen from ice core sample data. That's what I've been writing about. And what else you see is that as the sun gets more active, it's obvious getting more active, and the curve towards the year 2000 showing that it's getting more active, going up in sunspot numbers going up, is accompanied by cosmic radiation that's impacting Earth. So as the sun gets more active, the cosmic radiation goes up. What does that show? That shows the cosmic radiation is not coming from outside the solar system. It's coming from the sun itself. Only the sun that's becoming more active would be producing more cosmic radiation. And there are measurements of the interplanetary magnetic field also increasing by a factor of 2.3. So if the interplanetary magnetic field is increasing, that means that if there are cosmic rays coming from outside the solar system, that this will stop more cosmic rays from coming in, not allowing more cosmic rays to come in, the other way around. So there's only one possibility then. The sun is the source of the cosmic rays. Now they're launching a probe right at the sun when it's emitting more and more cosmic rays. That's very strange. But maybe they don't know that, Scott.
I don't know, but you know, I mean, you know, in my opinion, that's pretty impressive. That's pretty impressive.
It must be, because, I mean, they're talking about the heat shield. They didn't talk about a cosmic radiation shield, cosmic ray shield. They didn't say anything about it. So we can only assume this craft is only shielded against heat, not cosmic radiation. So I don't think it will get very far.
You know, I mean, if it does, it's going to depend on what's happening with the sun. And this is a current view from the SDO. And as you can see, ladies and gentlemen, you know, we don't get that ultra high definition that the boys in blue get. We get the public access version. So we know damn well that it could be much clearer, but we're not going to get that. But, you know, NASA has it. But we do have a pretty active region moving towards Earth. And I've been talking about it for a couple of days. You can see it. It's right here. It's right along the equatorial region of the sun. That's basically right where we are. As a marker, the little stop button on the video player, I'd say, you know, just a little bit below that would be Earth. It'd be a very, very tiny speck. You can see the size of this active region on the sun. Last year, we had a similar situation We kind of lucked out because that same active region, which was about as big as this, passed right by. And then it got right over here. And as it was turning away from Earth, a massive X flare exploded from the sun.
Yeah, that was June 9th.
Everywhere.
June 9th. And you know, it had been 12 years since the sun had had a major solar flare at that time. And that was June 9th of 2017. And in March of that same year, the sun went through a period of 15 days where it had no sunspots at all. So it was like it had reached solar minimum then, and then suddenly in June it became extremely active.
Well,
how does that happen, Scott? And that's why I've been writing these articles, because I believe the stellar cores are causing both. The stellar cores by drawing energy from the sun or weakening it, so it becomes weaker and weaker. Yeah. But whenever a new stellar core comes into the sun's corona, it actually provokes it into having these very energetic events. And because the sun's getting weaker, and when it has less energy, it affects its gravitational influence. That's what I found out. So it's not able to hold on to its plasma as well. So whenever a large stellar core comes into the sun's corona for the first time, it's just arrived in the solar system, that's when it can cause the sun to have these huge explosions. That's why we're seeing both things, the sun getting weaker and weaker and becoming more active at the same time. But it only happens when a new large stellar core arrives at the sun's corona. So we know what most likely happened on June 9th is that a very large stellar core, one of the larger ones, arrived at the sun's corona, and provoked it into that kind of thing.
Well, you see all kinds of things flying all over the place. I've never seen that on the SDO footage before.
Yeah, that is strange.
It flies right around here. I don't know what it is, folks. You know, there's all kinds of freaky things that we see. I'm going to go back over here real quick.
Yeah, I think there's a lot going on around the sun. There are more and more stellar cores there drawing energy from the sun. And and we caught that, you caught that object moving close to the sun and leaving that trail. I actually calculated its minimum speed, which was very surprising. Would have been about 4,000 kilometers per second or so. It's a huge speed. It's obviously interacting with the sun in a way that we've never seen before. And this is why they don't want us to know about this, because, you know, it just changes all the physics we've ever been taught. We can tell that it's just impossible. That the theories that we've been taught are true, and yet we have things like this actually happening. So, you know.
It's definitely going to be very interesting. I can't wait. I cannot wait.
Scott, I think what they will do is actually give us a movie. You know, give us the story of what's supposed to be happening. It may actually just be fiction, but they will tell us as if it's the truth. I mean, if this spacecraft that's funny, is launched and it's destroyed immediately, that they'll just tell us a story about. You know, they will even see all the people in the control room clapping and so on.
Yeah, the voiceover cheering.
Yeah, all the scripted stories they will tell us about this wonderful spacecraft that's getting closer and closer to the sun. And then they'll give us a whole lot of CGI. Oh, NASA's very good at CGI, don't you think?
Oh, absolutely. Check it out, folks. The other day, I ordered my glow ball. This is this real hard plastic replica of the surface of the moon, and it's completely wireless. It has a little button here which you just touch, and it changes colors. It even came with a remote control. But I thought it was pretty cool. A friend of mine got one. It's called the Glow Ball. You could find them online. Yeah, but it's a complete replica
reproduction of the moon's surface. It's amazing.
Yeah, after they mapped it. Mm. Maybe they'll be out there mapping the sun.
Oh, yes.
You know what this reminds me of?
What?
It kind of reminds me of Twatter's little bald head. Yeah. What do you think of that, Twatter? Rub your little glow ball. Yeah, folks, if you want one of those glow balls, just check it out online. You can find them everywhere. Mine was about $50. I got the bigger one. Pretty cool. But anyways, Dr. Albers, I wanted to thank you very much for coming on here, lending us your scientific background. Sorry I was laughing so much about the some of the things that NASA was saying there. It just it cracked me up.
They want to treat us like children with stories that don't make any sense. You know, we just have to ask the right questions. I mean, how are you going to actually get this spacecraft to the sun when we know what's going on with the sun? But obviously, maybe they don't. I mean, if they know nothing about the corona, how do they even know that the spacecraft will maintain room temperature inside it with this kind of heat shield? How do they know
there's a lot of questions. There's a ton of questions, man. I mean, listen, I wish I could be there, you know, on the launch pad, or I wish I could be there in the last development stage this next week or two. You know, because I have a whole bunch of questions. But you know what, folks? This is what we're going to do. We're going to sit back and we're going to watch their production, and they'll stream it live. We'll see the launch. And then, you know, I don't know when we'll get some immediate direct information. There may be some updates on their communication with the probe. But, you know, it's probably going to be quite a bit of time. But I also think that it's going to make some analyzations of Venus on its way through, and maybe Mercury. We'll see, because Mercury is like 44 million miles from the sun, and this probe's going to go way past it, 3.8 million miles away from the sun in the far reaches of the outer corona. This should be interesting. But anyways, folks, stay tuned. Make sure you are subscribed. Make sure your notifications are set, because you know how YouTube monkeys around with that. And we'll have updates, you know, as much as possible. I'm going to be doing a lot more live streaming because YouTube is just playing around with the uploading process for Dr. Albers and I. A 5-minute video with my high-speed internet access is taking between 2 and 4 hours. I've had everything tested on my end. There's absolutely nothing wrong on my end. So that's only telling me one thing. A 5-minute video that takes 2 hours. I've even tried to compress the videos. That did nothing. They don't want us uploading 3 or 4 videos a day. They're barely letting us get 1. I uploaded the same video to Real.video, our new platform that we're moving to. That same video took 3.3 minutes. 3.3 minutes to upload. So you tell me who's trying to make us go away. I'll leave you with that. Dr. Albers, thank you very much for being with us.
Well,
ladies and gentlemen.
Scott, it was interesting. We had a good laugh.
Yeah, no doubt. You know, and as the information pours in, I'm going to be laughing a hell of a lot more. And ladies and gentlemen, go to that NASA site. Analyze some of those interview videos where these NASA representatives are actually talking to you. Analyze their body language. Analyze what they're saying. Take a look for those symbolisms like I showed you already. You will see them. No doubt about it. Listen, everybody, be safe out there. Watch the weather very, very closely. Stay tuned to Planet X News. We'll see you soon. Take care.